Last night, I'm doing the equation about Maxwell equation. There is four Maxwell equation, right? I'm a bit confused about equation about Gauss law. That is because there is two equation about this law.
Oh, regarding the first and the second law of Maxwell, I actually found a YouTube video that explained both of these equation in one video. So why don't we watch it together?
Hello everyone! In today's video, we are going to learn about one of the important topics in electromagnetism, which is Maxwell equation. Maxwell equation is important because it explains how the electric charges and electric current produce magnetic and electric fields. The equation describes how the electric field can create a magnetic field and vice versa. There are four Maxwell equations, but in today's video, we are going to learn about the first and the second Maxwell equation. The third and the fourth equation, we are going to look at it in the next video. The first Maxwell equation states that the divergence of electric field is equal to the charge density over the permittivity of free space. This equation is based on the Gauss law, which states that the total electric flux through any closed surface is equal to the total charge enclosed by that surface. From the definition of Gauss law, we can use the integral of volume charge density, surface integral of electric flux density, and the divergence theorem to obtain the volume charge density is equal to the divergence of electric flux density. Since D is equal to epsilon naught E, we can substitute this in the equation to obtain the first Maxwell equation, which is the divergence of E is equal to the rho V over epsilon naught. Next, Maxwell's second equation states that the divergence of magnetic field is equal to zero, which related to magnetic monopole. Maxwell's second equation is based on the Gauss law for magnetism, which states that the net magnetic flux through any closed surface is zero. Magnetic flux is equal to the surface integral of magnetic flux density. Therefore, by using the divergence theorem, we can prove that the divergence of B is equal to zero. For magnetic fields, field lines form continuous loops indicating the absence of magnetic monopoles. For every magnetic field line that enters a closed surface, another magnetic field line must exit. Magnetic field lines form closed loops and there are no isolated north or south magnetic poles. The first and the second Maxwell equation has many applications in our real-life situation. That's all for today's video. I hope you have a clear understanding about the first and the second Maxwell equation. See you in the next video.
So do you understand, Faiza? Yes, that's very helpful. I'm finally understand the concept. Thank you.
Atira, the problem that I'm solving right now involves the Faraday's law, but I find it difficult to understand about the concept to solve this problem. So can you help me to understand the concept of Faraday's law in the Maxwell equation?
Yes, of course I can help you. Now, look at this.
Huh? Maxwell for Faraday law? Easy.
3, 2, 1.
These are the formula of Maxwell-Faraday equation. The integral form of the Maxwell-Faraday equation describes only the transformer EMF, while the equation of Faraday's law describes both the transformer EMF and the motional EMF. The Maxwell-Faraday equation, listed as one of the Maxwell's equations, describes the fact that a spatially varying and also possibly time varying, depending on how a magnetic field varies in time, electric field always accompanies a time varying magnetic field, while Faraday's law states that there is EMF defined as electromagnetic work done on a unit charge when it has traveled one round of a conductive loop. On a conductive loop, when the magnetic flux through the surface enclosed by the loop varies in time.
Oh, I see.
Aiza, for the last Maxwell equation is Ampere's, right?
Yes. Why?
Can you explain it to me? I did some revision about Ampere Maxwell law. Why don't you travel to my mind?
Ampere's Maxwell equation is based on Ampere's circuit law. To understand more about this equation, we need to understand Ampere's circuit law first. Ampere's law states that the magnetic field created by an electric current is proportional to the size of the electric current, with a constant of proportionality equal to probability of free space. Stationary charge produce electric fields and moving charge produce a magnetic field. There is an electric current, there has to be a magnetic field vector around it with a steady current. James Clerk Maxwell, Scottish physicist, who is the one found that the Ampere-Maxwell equation. He found that the effect of changing electric field can indeed create a magnetic field even in the absence of a physical current. This phenomenon is described by the concept of displacement current, JD. Maxwell understands that displacement current can be thought of as a form of current that arises from the time-varying electric field. From the equation Ampere's law, we substitute and doing the Stokes theorems, then we get the Ampere's Maxwell equation. From this experiment, we can say that a changing electric field produces a magnetic field.
So guys, I think we finally have a clear understanding on the four Maxwell equation, right?
Yes! Let's go have a lunch.
Let's go!